Okay, question 1. So just looking through, seeing what I need to underline. I've got a polynomial. Here it is. That's obviously important. I've got a question about this being a factor of that, and I've got to show that. That's trigger words. K is 10. Just looking a little bit further down, I can see remainder theorem cropping up. So I'm talking about factors. I'm talking about remainders. So I'm going to be using the factor remainder theorem method. Okay. So let's just look more closely at part A. I know this is a factor. Okay, show that. That means my my end point is going to be that k equals 10, and I've got to get there convincingly. So I can leave that on one side to begin with. I need to start. This is my start point. X plus 2 is a factor. So if I know that x plus 2 is a factor, then I know that there is a magic x. So magic x is when x plus 2 equals something specific, and that's going to lead to a particular value of x. So that's in brackets because you could actually get away without writing that, but that's your thinking behind saying what you do need to write. X plus 2 as a factor means that, okay, something, p with some value, the magic x substituted in, equals a particular value that applies when it's a factor. Okay, so how do you put that into operation? Well, here was your polynomial p, so we've now decided we're substituting something in. So you put that x value in, and the result must be 0. Now, as you can see, p of x contains a k, so after you set this up, okay, p of something equals some particular answer, then you're going to have a load of stuff. You're going to have a bracket, cubed, and some other stuff, and you're going to have the plus k on the end of the polynomial, and the answer has to equal that specific value. Okay, so everything is numbers apart from this k, so after a couple of lines you're going to be able to get what k is, and because it's a show that question, you're absolutely sure that you're going to get to k equals 10, meaning there are no marks for that, because everyone's going to finish with k equals 10. You've just got to get there convincingly, but you still must write down k equals 10, otherwise you haven't finished and you'll lose marks. Okay, so that was the first part. Then the next part, now, okay, we've got to use that knowledge about one factor to actually turn it into 3 factors. So we've got to completely factorize p of x. So now I need to actually think about how I can make p of x by a product. So it's the grid method. So in this one here, okay, we already know one factor. So the factor you know goes down the side of the grid. This is the method from your notes. So you're going to be writing your x cubed minus 4x squared minus 7x plus, you now know what k is, okay, equals the factor you do know times another factor, okay, so it's going to look like this, okay, and you're going to be able to fill in this bracket once you've completed the grid in the normal way, and the grid should work out perfectly with a remainder of 0 because we already know that this was a factor. Okay, and once you've got it in this form, this is in the product of 2 factors. This one here, you need to factorize again in the normal way, and you're going to end up with the product of 3 factors, and that's going to be your answer. Okay, on to part B. All right, now we've got to use the remainder theorem to find the remainder when p of x is divided by this. Now, this is a re-entry point, okay? We do not have to have answered a dot e2 or even a dot e1. A dot e1 is kindly telling us what k equals. Okay, so I can come in on B and use the remainder theorem. But in part B, okay, the remainder theorem again depends on a magic x. It's going to be a new magic x, okay? So there'll be a new magic x when something else happens, and there'll be another value of x, and I'm going to be doing p of that value of x, okay? And I'm going to be very clear that my answer is telling me that the remainder equals something, so I'm going to be very clear about what I have found. And then in part C, what we've got to do in part C, we have got to sketch this curve, okay, indicating, all right, so always read what you've got to find, indicating where the curve crosses the x and y axes, okay, but I don't need to find the coordinates of any stationary points, okay, so I'm just dealing with x-intercepts, y-intercepts, and obviously the shape. So it's your 3-stage approach to finding graphs, okay, cubic graphs, okay. With quadratics you may have to find a vertex, but we don't have a vertex of a cubic. So you're going to consider the shape. So what part of our cubic function do we need to look at to get the shape? Well, one of these coefficients will tell you which way kind of up it is. All right, so the shape, and then you're going to need to think about y-intercepts, and that's a standard thing you do whenever it's a y-intercept. Okay, something is going to equal 0. And then for the x-intercepts, okay, something is going to equal 0. Okay. Now, one of these, this one is just substituting the value in. This one here, we're going to have to solve an equation. So we're going to have to solve something equal to 0. Okay. Now, what would I like this to be? I'd like anything I want to equal 0 to be factorized. Okay, so if only this thing was in 3 brackets. Oh, earlier in the question, if you were successful up here, you did factorize what you need. So in fact, all you need to do from this is to generate your 3 x-intercepts. Okay, you've got a y-intercept, you've got a shape. And so you just got to draw it nicely. And you've got examples of sketching cubics at the very end of your booklet, one of your notes. So I think you're going to be all right on this question. Oh, just one last thing. If you've found these things and got very clear lists of what's going to be on your sketch, please remember to actually put it on the graph, okay? If it asks you to label x and y intercepts on your sketch, then you're pushing your luck if you show them somewhere else. In fact, I wouldn't give it the marks if it was me. So show the x and y intercepts clearly on your sketch.